गुड आफ्टरनून क्लास। लास्ट टर्न पे हम लोगों ने एसआर फ्लिप फ्लॉप को डिजाइन किया था बाय यूजिंग CMOS। उसके लिए हम लोगों ने दो तरीके के लॉजिक्स पढ़े थे। एक हम लोगों ने 8 ट्रांजिस्टर लॉजिक पढ़ा और फिर पास ट्रांजिस्टर का यूज करके हम लोगों ने 6 ट्रांजिस्टर लॉजिक के मदद से भी एसआर फ्लिप फ्लॉप को डिजाइन किया। आज के लेक्चर में हम लोग डी फ्लिप फ्लॉप को डिजाइन करना सीखेंगे और इसके अलावा ये भी देखेंगे कि जेके फ्लिप फ्लॉप को हम कैसे डिजाइन कर सकते हैं। ओके, तो डी फ्लिप फ्लॉप, तो डी फ्लिप फ्लॉप मींस वेयर फ्रॉम वेयर दिस डी हैव केम। तो डी फ्लिप फ्लॉप मींस डी फ्लिप फ्लॉप, डी फ्लिप फ्लॉप मींस D flip flop means data flip flop oblique delay flip flop. Sometimes it is used as data flip flop and sometimes it is used as delay flip flop. SR flip flop के मदद से हम लोग JK D flip flop को बना सकते हैं। कैसे बना सकते हैं इस चीज को देखते हैं। एसआर फ्लिप फ्लॉप में जो भी आपका Qn+1 होता है जो कि कैरेक्टरिस्टिक इक्वेशन को रिप्रेजेंट करेगा, Qn+1 विल बी इक्वल्स टू S प्लस R बार Q, S प्लस R बार Q। ओके, अब यहां पर हम लोग अगर S इज इक्वल्स टू D पुट कर दिए एंड R बार की भी वैल्यू को हमने क्या पुट कर दिया, D पुट कर दिया। तो R बार की वैल्यू को हम D कैसे पुट कर सकते हैं? R बार की वैल्यू को D पुट करने का तरीका ये है कि हमने R की वैल्यू को क्या पुट कर दिया, D बार पुट कर दिया। तो अगर हम ऐसे यहां पर पुट करेंगे तो इन दैट पर्टिकुलर केस Qn+1 विल बी इक्वल टू D प्लस DQ, D प्लस DQ। तो Q की वैल्यू चाहे 0 हो या फिर 1 हो, किसी भी कंडीशन में Qn+1 की वैल्यू क्या आएगी, Qn+1 की वैल्यू D ही आएगी। इसका मतलब यहां पर जो आपका D फ्लिप फ्लॉप है उसमें जो नेक्स्ट स्टेट आएगी दैट विल बी इक्वल टू D। ठीक, तो ये D मतलब जो भी डेटा आपका इनपुट रहेगा, वॉट एवर डेटा वी आर गिविंग एट इनपुट वी विल गेट इट एट द आउटपुट। ओके, तो मीन्स पहली चीज तो ये है कि क्लॉक के आने पर डेटा एक पॉइंट से दूसरे पॉइंट पर पहुंच रहा है। वंस द क्लॉक विल अराइव, डेटा विल बी ट्रांसमिटेड फ्रॉम इनपुट टू द आउटपुट। Okay, first thing is this, and second thing is this, that since this data will go through different circuitry, this data will pass through different circuitry, so we may say that if we will pass through 4 transistors, 5 transistors, so certainly being passed being passed through one transistor there will be a certain delay, and in being passed through 5 transistors or 6 transistors there will be large amount of delay. Means we can delay the data. If we want to transmit the 0, so 0 will come at the output after certain delay. If we want to transmit 1, then 1 will come at the output after certain delay. So that's how this D flip flop is used here as data flip flop or delay flip flop. Okay, in my thought, the basic concept of D flip flop is now very clear to you all. So how we can design a D flip flop? While designing in D flip flop, we will need number one, 2 inverters. This inverter number 1 is G1 and inverter number 2 is G2. Okay, here is a MOS, that is NMOS, and here is a MOS, that is NMOS. With that, this particular MOS, their gate, on the gate, the phi signal is applied, and here phi bar is applied. Okay, so here D means data is being transmitted from one point to the another point. Data is being transmitted from one point to the another point. Okay, so here if we are transmitting 1 or 0, suppose there is certain data, any data, that is D. Okay, D is equals to 1 in case 1. Okay, so if we have named it here as a Q1 and we have named it here Q2, so how Q1 will behave? Q1 will be short circuit. Q1 will be short circuit. Q1 will behave as short circuit. When Q1 will behave as short circuit? When phi is high. When phi is high. Okay. And similarly here, Q2 will behave as a short circuit since on the Q2 the input is phi bar, so Q2 will behave as short circuit when phi is low. So here we will get the short circuit and open circuit depending upon the pulse. Okay. So first of all, if pulse is high, okay, number one thing is pulse is high. How we can design inverter? We have already seen that how we can design inverter using CMOS. Okay, these particular CMOS will have certain capacitance and data will be stored in that particular capacitor. Okay, and otherwise whatever data it will be high, then capacitor MOS capacitor value will hold high data, and if data will be low, then MOS capacitor value will hold low data. Okay, so number one thing, if phi is high, if phi is high, then what will happen? If phi is high, then Q1 will behave as on, and if Q1 will behave as on, then definitely we can say that it will behave as a short circuit. So whatever data D will be transmitted to input of inverter G1, okay, input of inverter G1, okay, and similarly it will be transmitted to input of inverter G1. And number two is, if so input of inverter G1, if D is high, suppose D is high, agar D high hai, if D is high means it is 1, so input of inverter G1 here what will be value? 1 or high. So here at the output of inverter, here value will be 0. So we can say the Q bar value will be 0, means it will store less data. Okay, so here will be Q bar. Okay, and it will behave as input of G2, inverter G2, and now this particular case here output will be 1. Okay, so here at the input we have transmitted what data? We have transmitted 1 and we have obtained Q is equals to 1. Okay, now what will happen? Sir, this is true only for phi is high. If phi becomes low, then what will happen? If phi is equals to low, if phi becomes low, then what will happen? Now, if phi becomes low, then in that particular case, this Q1 transistor will behave as how? It will behave as open circuit, means it will be cut off. And the Q2 transistor will behave as on or short circuit. So now this Q2 transistor will behave as short circuit, and now the data 1 which will be input here. Here will be a positive feedback path, and here 1 will remain. Means in any case, if data is transmitted as 1, then output will remain 1 regardless phi is low or high. Once phi will become high, then data will be transmitted, and if again it becomes low, then there is no problem. Okay. Now suppose if data is equals to 0 and phi becomes high, then definitely here output will become 0, this will become 1, this will become again 0, and this will become, so this is 0. Okay. And again for once phi will be high, then 0 0 will be on both side, and if phi becomes low, again this condition will be followed. Okay, so I hope you have understood how D flip-flop particularly works. Now after seeing this, that how D flip-flop particularly works for phi is equals to low, phi is equals to high, data is equals to 1, data is equals to 0, now we are up to design of CMOS implementation. How we can implement it, how we can implement D flip-flop using CMOS. Okay, so as you can see, the circuit will remain very easy. How? If D, here it is, here it is, here it is, this is phi, this is D, here we will design inverter, here ground, this is PMOS, this is NMOS, here it will be VDD. We have implemented here G1, and here output will be, you can say that this particular pin will give Q bar. Now this will go as input to another inverter. This is VDD. Again this will be ground. Here Q. Okay. And here we'll have a feedback path working between these two. Here input will be 5. So this is how we can implement D flip-flop using CMOS. Simply at the where in the basic circuit we have used inverter, we have replaced it by the CMOS inverter-based circuits. Okay, and here is also, if there are two master-slave flip-flop, how master-slave flip-flop can work. D flip-flops are cascaded with the master and slave. So there will be two pulses. One will be connected phi 1 will be connected here, and again the second one will be, here will be phi 2, and phi 2 will be connected here. So this is how we can implement D flip-flop. Okay. If you have any doubt in D flip-flop, then you may ask.